All right, how's it going, guys? Today we're going to be talking about converting from standard form to vertex form. And what the standard form of a quadratic equation is, it's going to be y equals ax squared plus bx plus c. And what a binomial is, it's going to be an expression with two terms. A good example of that is just going to be x plus 5. It's going to be two distinct terms that cannot be added together as is. You can't add x or 5 together, so x plus 5 is a binomial. A perfect square trinomial is the square of a binomial. For example, x plus 5 squared, that is going to equal our perfect square trinomial, which is x squared plus 10x plus 25. Okay, and when we're talking about vertex form and standard form, a standard form of an equation isn't going to tell us all too much. So what we want to do a lot of the times is we want to take a standard form of an equation and we want to convert it to the vertex form. So in these problems here, what we want to do is we want to rewrite each quadratic function into vertex form. And then we're going to identify if it's a maximum or minimum and what that maximum or minimum value of the function is. So for the first one, what we're going to do first is we want to isolate the first two x values. So we have x squared plus 6x minus 5. So we're going to isolate the x squared and the 6x together in a parentheses, but we're also going to add a third term that we do not know what it is yet. It's going to be a blank minus 5, and we're going to minus a blank. Okay? So from here, what this blank is going to be, it's going to be b divided by 2 squared. And what we add into the parentheses, we have to minus outside of it as well. So outside, it's going to be the same thing, b divided by 2 squared. We cannot change the value of the equation, of the function. So if we're adding b over 2 squared, we also have to minus it somewhere else as well. That will keep the value of the function the same, since b minus 2 squared minus b divided by 2 squared equals 0, right? So anyway, let's go ahead and solve it out. Our b value here is 6. So we know our b divided by 2 is going to give us 6 over 2, right? Our b over 2 squared is going to give us 6 over 2 squared, which is going to give us 3 squared. So let's go ahead and put that into the equation. X squared plus 6x plus 3 squared, all of that, minus 5 minus b over 2, which we said was 3, and then we square it, so 3 squared as well. So what we want to do now is we want to take what's inside the parentheses and we want to change it into a binomial. After we do this process, which is called completing the square, we now have a perfect trinomial. So we want to take that perfect trinomial and change it back to a binomial. So when to do that, all it's going to be in the form x plus b divided by 2 squared. This is to change the parentheses into a binomial, the trinomial in the parentheses into a binomial. Okay, and what this b divided by 2 is, it's just going to be our 3. It's going to be the value we had before we square it. So we know that our vertex form now is going to be x plus this 3 over here, all of that squared. And let's go ahead and just add our like terms here. We have negative 5 minus 3 squared, which is minus 5 minus 9. Minus 5 minus 9 is negative 14. So this is how we get our vertex form. And from here, we're going to need to decide if it's a maximum or minimum. And to decide that, we're going to look at the a value over here. We see the a value here is just 1. And remember, if a is greater than 0, our graph is going to look like that. And if our a is less than 0, our graph is going to be reflected over the x-axis, and it's going to be facing downwards. But we're in the first case over here, so we're going to look at the vertex. That's going to be either our lowest or our maximum point. And we see the vertex over here is the lowest point on the graph, so we know we have a minimum. If a is greater than 0, it faces upwards, and we have a minimum. And the value of the minimum is going to be the y value of the vertex. The vertex is in form hk. So in other words, our minimum is going to be our k value, y equals negative 14. Okay? I'm going to let you guys do B by yourselves. We upload the completed notes with step-by-step instructions. So you'll see it on there. You double check your work with what we have posted on there and see how you do, what you understand and what you don't understand yourself, okay? Going on, these two also are very similar. But let's go ahead and do one of them. I'm going to do C. So the very first thing we're going to do again is we're going to isolate the very first two x terms. So you have x squared minus 4x plus the blank. And then we have minus 7. And if we're adding a blank inside the parentheses, we have to subtract that same blank outside of it. Okay? So, like we said before, that blank is going to be b divided by 2 squared for both blanks in this instance. So from here, let's go ahead and figure out what our b over 2 is. Our b is going to be -4 in this case. So you have b over 2 squared is going to be -4 divided by 2 squared, which is going to be -2 squared. So let's go ahead and put that into our equation. We'll have x squared minus 4x, don't forget the parentheses, plus -2 squared minus 7, and we'll add the same thing, subtract the same thing to the outside. So from here, let's go ahead and figure out what our binomial squared is going to be. Remember, the x squared minus 4x plus the -2 squared is a perfect trinomial, so we can actually go ahead and turn it into a binomial. So what it's going to be is going to be our x plus the b divided by 2. In this case, b is -2, so we have x minus 2, right? This right here is our b divided by 2, the number we have before we squared. So x minus 2 squared, and let's go ahead and figure out our k value over here. So we get -7 minus -2 squared is 4. So -7 minus 4, or -11. So our vertex is x minus 2 squared minus 11. And then from here, same thing. Is it a minimum? Is it a maximum? We can determine that by the a value. In this case, the a value is 1. A is greater than 0. So in this case, our parabola is facing upwards, so our vertex is a minimum. And remember, minimums and maximums are determined by if they are turning points. The vertex is the only turning point in a parabola, so we determine that by the vertex. The vertex in this instance is a minimum, and the y value of the vertex is -11. Okay, I'm gonna leave D for you guys to do on your own. So let's keep going. I want to look at F. In this instance, we have a 2 for the a value. So we're going to start this like we start every other problem. We're going to isolate the first two terms. You have 2x squared plus 12x plus a blank plus 10 minus a blank. Okay? So from here, what we're going to do is we want to actually factor out that 2 in front of x squared. We don't want it there. It's just going to make our life miserable. So let's try to make it as simple as possible by taking out that 2 and factoring it out. So we take this 2 and we factor it out. Remember, we have to do that for every single value inside the parentheses. So we take the 2 out. We're left with x squared plus 6x, right? What we take out, we divide by everything inside the parentheses plus some blank. And then we have plus 10 minus another blank over there. Okay? So from here, what we're going to do is we're going to solve it how we normally would now. We're going to kind of ignore the 2 for now, but we're going to solve the parentheses how we usually do. Okay? So we have 2x squared plus 6x plus this blank is going to be the b divided by 2 squared. Our new b is what we use. We use what's inside the parentheses. Our b here is 6. So we have 6 divided by 2 squared, and close the parentheses, plus the 10 minus a blank. We're going to deal with that blank in a little bit. Let's go ahead and work this down. So 2x squared plus 6x plus 3 squared plus 10. And for this blank over here, what it's actually going to be is going to be this value we have here multiplied by the A value that we factored out. And why we do that is because, remember, we need to keep the value of the equation the same. And what we're actually adding to the left side is that 3 squared multiplied by 2, right? We factored out that 2 from the 3 squared before, or the 9. So what we actually added into this equation was actually 18. So 2, remember, if you distribute the 2 back out, what we actually added was 18. So if we added 18, we also have to subtract it. So let's go ahead and minus the 18 outside over here too. So it's just going to be the value, the b over 2 squared multiplied by the a that you factored out. So from here, we just solve it how we normally would. We have a perfect trinomial inside the parentheses. So let's go ahead and turn that into a binomial. And that's still going to be the same thing. It's just going to be the b divided by 2. So it's the x plus 3, all of that squared. We have 10 minus 18. That's negative 8. So this is what our vertex is going to be. 2 times x plus 3 squared minus 8. So now let's try to figure out if it's a minimum or maximum. Our a value here is still above 0. It's greater than 0. So we still have a minimum, right? Because if a is greater than 0, our parabola is going to be facing upwards. It's going to look like a U. So we know we have a minimum, and our minimum is going to be when the y is going to be the y value of the vertex, because the vertex is the smallest point when a is greater than 0. So we need the y value of the vertex, or in other words, the k. So y equals negative 8. Let's keep going. Here we have some instances when we have a negative a, and we solve these the exact same as we would as the previous problem, okay? We're just going to isolate the very first two values, right? The two x's, so negative 2x squared minus 8x plus 3. We're going to go ahead and isolate the first two, negative 2x squared minus 8x plus a blank, then plus 3 minus a blank. We add a blank, we minus 1, that's the same thing. So from here, what we're going to do is we're going to take out that negative 2. It's just going to make our life a hassle. So let's just go ahead and get rid of it and simplify this as much as we can. So we take a negative 2 out. We have negative 2x squared. When we take negative 2 out of negative 8, remember we divide it. So negative 8 divided by negative 2 gives us a positive 4x. And then we're going to add this blank over here, which remember is b all over 2 squared. And we're using our new b of 4. Plus 3 minus the blank. And then from here, our b is 4, like I said. So 4b divided by 2, or 4 divided by 2 is 2. So let's go ahead and put in our b here. So negative 2x squared plus 4x plus 2 squared, all plus 3. And what we put here is going to be our 2 squared multiplied by the negative 2, right? Because that's how much we're actually adding into the function. 2 squared is 4. 4 times negative 2 is negative 8. So we subtracted, actually, in this instance, negative 8. We subtracted 8 from the parentheses. So what we need to do is subtract 8 again on this side. So we have negative 8 here. We're going to go ahead and put a negative 8 over here as well. So let's go ahead and solve it out now. We can make this perfect trinomial inside the parentheses into a binomial. So we get negative 2. We get x. 4 divided by 2 is 2, so it's x plus 2. All of that squared. And then we have plus 3, positive 3 minus negative 8. 3 minus negative 8 turns to 3 plus 8. So we get plus 11 over here. So in this case, our vertex is going to be, a vertex form, sorry, is going to be negative 2 multiplied by x plus 2. All of that squared plus 11. And here we have our a is less than 0. And when a is less than 0, remember we reflect over the x-axis, so we are opening downwards instead of up. So in this case, our vertex is our maximum point. So we know we have a maximum at y equals 11. And remember, the maximum is going to be the y values. It's how much the function is worth at that specific point. So it's y equals 11. It's the y value of the vertex. In other words, it's just k. And I'm going to leave H for you guys to do as practice. And you can always double check yourself with the completed notes that we post online. Going on, now we're going to look at a word problem. We're going to look at how to actually apply this to real world scenarios. So applications analyzing projectile motion model. Projectile motion can be represented by the model h of t equals negative 16t squared plus v of 0t plus h of 0, where v of 0 is the object's initial vertical velocity, and h of o is the object's initial starting spot. If I can get this thing to pop up. Well, h of 0 is the initial starting height. Okay? It's the initial starting height. Okay? So let's go ahead and read this problem and try to solve it. A golf ball is hit with an initial upwards velocity of 64 feet per second off a 6-foot-high platform at a driving range. The motion of the ball can be represented by the model h of t equals negative 16t squared plus 64t plus 6. How long does it take the ball to reach its maximum height? So in this instance, our graph is going to look more or less something like this, right? We have our a is negative, so we know we're facing downwards, and what we're asked for is the maximum height it will reach. We swing and we hit a ball, it goes upwards in a parabolic shape before it goes back down, so there's a maximum height, and that maximum height, remember, will be the vertex. So if we want the maximum height of the vertex, that means we want the k value, the y value of the vertex, right? That's what we want. So let's go ahead and try to solve it. We can't really get the vertex when it's in standard form. It's just going to be too much work, too much trouble than it's worth. So let's go ahead and change it into vertex form, and we're going to do that with completing the square. So we're going to start like we always do. Isolate the very first two values, the negative 16t squared plus 64t plus a blank. Go ahead and erase this graph, give me a little more room. Then plus 6 minus another blank. We add a blank, we minus the blank. We have to keep the function's value the same. So from here, we have this negative 16 over here, and the a value, we don't want that. So let's go ahead and get rid of it. We can take it out. We get negative 16 multiplied by t squared. 64 divided by negative 16 is negative 4t, right? And then plus our b divided by 2. In other words, our negative 4 divided by 2, which is negative 2. And we're going to square it. And then we plus 6. And what we're going to minus over here is going to be the negative 2 squared, or in other words, 4, right? Negative 2 squared is negative 2 multiplied by negative 2, which is 4. And then we multiply 4 with negative 16. Negative 16 multiplied by 4 is 64, a negative 64, sorry, because 4 times 16 is 64, and we have a negative, so it becomes a negative. So our value outside is going to be negative 64. So let's go ahead and put this to the vertex form now. We get everything that we need. We have negative 16 multiplied by t. It's going to be plus our b divided by 2. Our b is negative 4, so it's negative 2. Or in other words, it's this number over here that we have before we squared. So it's t minus 2, all of that squared. And then we have plus 6 minus 64, which is 6 minus negative 64 is the same thing as saying 6 plus positive 64, or just 70. Our vertex, remember, it's our hk value, so it's 270. Now we're asked for the time it takes for the ball to reach its maximum height. Remember, guys, time will always be independent. Time relies on nothing. So our time will always be the independent variable, which is x. X is the independent variable. So please remember, time will be x. So time is going to be our h value here. So we know it takes 2 seconds. And then the height that it reaches, it's going to be the maximum height that it reaches. It's going to be the y value of the vertex, because y in this instance is our height. So in this case, our height is 70 feet. And for the other word problem, I'm going to leave that for you guys as well. Like I said, we will post the completed notes on Canvas as well, so you can try it yourself. Double check your work. If you don't get it, rewatch the video and try to figure it out on your own. And you can double check your work with the notes on Canvas.